injection, you might be able to call some time delay functions. And lastly, you can also do out-of-band channels in Oracle. So all these exploitation techniques are fairly common between Oracle and MS SQL, and they're not very different. What I'm more interested in is privilege escalation and OS code execution. So this is actually an important point. So you found a SQL injection, and you are injecting some code via this SQL injection from the web application front end. Now, depending on by what privileges your injected query gets executed, I will classify a particular SQL injection as privileged or unprivileged. So for example, a typical privileged SQL injection would be when whatever I am injecting, whatever SQL I am injecting, gets executed with DBA privileges. Now, it could happen in a number of scenarios. For example, the application itself connects to the database with DBA privileges. It is not very common to see developers doing that. I mean, having said that, you often come across applications in ASP and ASPX where you see the application connects to the database with SA user or any user with sysadmin role. So it's not very common, but you still come across these. However, more importantly, you can see DBA privileges in your SQL injection when the SQL injection is in a procedure and that procedure is owned by a high privileged user. So the application might connect to the database with Scott Tiger permissions, standard permissions, but the injection point is in a procedure, and that procedure runs as a high privileged user. So in that case, my SQL injection will be privileged, irrespective of the connection string. And obviously, the second category could be the unprivileged SQL injection. For example, I mean, if you only have a typical Scott user privileges, that would be an unprivileged SQL injection. So what I mean by privilege escalation is I know that during interactive exploitation, like if I can fire a Razor SQL, or sorry, any SQL client, SQL Plus to the Oracle database, then I might be able to run a procedure which is vulnerable to SQL injection, grant myself DBA permissions, and then I can do stuff. That is a typical privilege escalation. Now, those of you familiar with MS SQL more, you may recall MS SQL, it is still possible to do privilege escalation by calling open row set. So I am after something similar in Oracle. And if you remember, I talked about that in SQL, Oracle does not support execution of multiple statements. So you cannot, if there is a SQL injection typically which exists in a select statement, then you are only restricted to select statement. So you cannot end that statement and call a procedure and inject into it. What you can do is call functions in the SQL, because SQL supports functions. You can call functions within the SQL. So for exploiting SQL injections, we are typically looking for vulnerable functions. Any function which has any vulnerability typically can be used via exploiting SQL injections. So we are looking for functions which are executable by public and are vulnerable to either PL/SQL injection or allow PL/SQL execution as a feature. So we will call the function in the SQL, and as an argument to that function, we pass PL/SQL. There are a few such functions known, but the exploit is not publicly available. For example, this particular function, DBMS Java test, a function in this is the name of the package. A function exists within this package which had a buffer overflow vulnerability. So in your SQL, you can call this function and cause a buffer overflow because that function is executable by public. So out of those few known exploits, the one which is fairly popular is this particular function, get domain index tables. This function is vulnerable to PL/SQL injection. Now I have the example of the exploit code in the next slide, but before we go there, so this function runs with the definer privileges. So irrespective of what privileges do you have, you can call this function, and you can inject some argument within this function, and whatever you inject, that will run as sys. So you don't really care about any privileges, and you can directly query the database with sys privileges. So it allows privilege escalation and OS code execution from web apps. Public can execute this function. So this flaw is fairly old now. This was fixed in CPU of April 2006, and these are the vulnerable versions. And sadly, I mean, there are no more functions known. As I said, there have been advisories published which says these functions are vulnerable, but the exploit codes are not known. And this is one particular exploit which is very popular, and all Oracle exploitation tools actually rely on this exploit. So this is how the exploit looks like. Essentially, if you look at this, then our injection string, which mainly is, I mean, we've injected quite a lot in it, but mainly that statement grant DBA to public will run as sys permissions. So this will just grant the DBA role onto the public user, and then you can carry out exploitation with DBA privileges. Right. Next, we move on to the OS code execution. Again, we can have a SQL injection which is unprivileged or privileged. And again, if your SQL injection is unprivileged, you can use this particular function to execute OS code via PL/SQL. Again, this is the only function which is known by which, with absolutely no privileges, you can do privilege escalation and execute OS code. I mean, you can still execute OS code, but for that, you need some privileges. You just can't do it with the bare minimum create session user privileges. So the privileges which are required for OS code execution are either a DBA privileges or Java IO privileges. I mean, so for example, in MS SQL, we know that you can execute OS code by calling XP_CMD shell. But to call XP_CMD shell, your user must be in the sysadmin role. Only then he can call the XP_CMD shell procedure. So that is basically a feature. So likewise in Oracle, if you have these two permissions, then you can execute code. And I would not call this as a vulnerability. This is essentially a feature, but just a feature which is probably not very well described by Oracle for obvious reasons. So I mean, before we move on to the privileged part, this is again the same exploit which was fixed in 2006. So we execute OS code by injecting PL/SQL within this function. A number of commercial tools like Pangolin and Core, which I've seen, they actually support this exploit, and that's the only exploit which they support. Bsqlbf is one such tool, which is one tool which I support, which also has this exploit, and we will look at some more exploits later on. Right. So moving on. Again, that was quite an old issue patched in 2006. If your connection string user, or if your SQL injection is such that whatever code you are injecting, that particular user has Java IO permissions, then you can execute OS code on an Oracle database. You can do that in 10gr2, 11gr1, and 11gr2 by calling these two functions, run Java and funcall. Both these functions, they take an Oracle class as an argument and a method of that class which will allow OS code execution. So by default, this particular Oracle class, Aurora util wrapper, allows OS code execution within the main method. So this is how the exploit would look like. All you do is basically just call this function, dbms java test.funcall. And as an argument, you pass the Oracle class and whatever code you want to execute. The only limitation is that you need Java IO permissions. And without Java IO permissions, you cannot call this class. You cannot execute this class. You have execute permissions on the function, but you cannot execute that class without Java IO permissions. So you can also execute code with DBA privileges. Now, when we talk about DBA privileges, obviously DBA is a higher level privilege, so the obvious question which arises is that DBA can grant himself Java IO permissions and hence go back to that step which we showed earlier and execute OS code. So what's the point? The point is that I wanted to come up with something generic. So for example, even if in future Oracle removes this Java class, or makes it difficult for you, or revokes the execute permissions of the public user on that particular function, then we still want to execute OS code. So in Oracle 10G and 11G, there is a function called create master process. This function executes arbitrary PL/SQL. This is not a flaw. This is a feature. You have to be careful with Oracle. So because it executes PL/SQL as a feature, what we do is as an argument, we pass on a PL/SQL, which essentially is a DBMS scheduler, and via DBMS scheduler, we can execute OS code. So this is how it looks like. It basically has a number of statements. First of all, we create a program. In that program, we basically tell Oracle that this program is to run this particular OS code with this particular argument. And then we create a job. Then we execute the job and drop the job. So this essentially will result in whatever code you want to execute. OK, so you don't have to remember any of that because it has already been scripted. And all you need to remember is the right switches to call. Bsqlbf, as I said, is a free tool which I support. And it supports advanced, it supports OS code execution by exploiting SQL injections against Oracle database. What's new in Bsqlbf is the new version, which I will be releasing now. It's already out there. Supports execution of any Metasploit's payload on the remote Oracle database. So I have a small video for you. Right, so here is a sample SQL injection. So we are doing a blind SQL injection here. So if you do 1 is equal to 1, then you see this particular string accounts appearing in the HTML page. If you do and 1 equal to 2, then you will see that disappears. So it's a quite standard blind SQL injection, which we are looking at. Right, so the new version of Bsqlbf actually comes with an executable. So if you go to the Bsqlbf folder, so there is a generator.exe and a Perl script. What you do is you choose the Metasploit payload which you want to execute on the remote Oracle database. So I mean, this is for example, in this case, we choose a remote VNC shell. And we choose our IP address on which we want the database to throw us a reverse shell. This will run MSF payload, which we will then upload via our SQL injection on the remote database, and we compress it for better results. It supports 2 modes of exploitation, as I said, Java IO and DBA. What privileges do you have? After you've finished it, it then tells you what to do next. So you have to launch Bsqlbf then, and with what parameters you should launch it. It's basically a small manual page which comes up. So it basically tells you. It also has a cleanup mode. So if you are doing a pen test, you probably do not want to leave Metasploit payload onto a remote database and things like that. So -cmd is equal to ref shell. That is a parameter which is new, which will execute Metasploit's payload. So you launch the Metasploit to capture your reverse shell. As you can see, my video editing techniques need some improvement. Right. So you launch Bsqlbf. You provide the vulnerable URL. You provide the match string. In this case, it was accounts, by which it identifies the true and false response. You provide the database, so it is 3 for Oracle. Type 8 stands for that we have the DBA privileges, and rev shell stands for execute the Metasploit's payload, which we have already created. So if we now start our Metasploit listener and let Bsqlbf does its job, then so it will first check if we have the Java IO permissions. Sorry, it was Java IO and not DBA. Then it will upload the corresponding Metasploit's payload. Depending on what payload you are executing, this can take some time. Metasploit 3.3, the payloads it creates are quite big, so it could take some time. Right. So when it's successful, it will drop you a VNC shell like that. So and Oracle in Windows runs as system, so this is basically complete ownage. This is fairly generic, so even if you come across an Oracle database,